Thank you. Allow me to take you through this question. You are provided with solution J. Solution J is ammonium iron 2 sulfate solution, and this is the formula. Solution K is 0.2 molar potassium manganate 7 solution. You are required to determine the molarity of ammonium iron 2 sulfate, the amount of water of crystallization N in ammonium iron 2 sulfate, the formula mass of ammonium iron 2 sulfate. The procedure: the ammonium iron 2 sulfate solution provided was made by dissolving 8.5 grams of the salt in 50 centimeters cube of dilute sulfuric acid, and then making the solution to 250 centimeters cube using distilled water. So this is solution J. Fill the puree with solution K, pipette 25 of solution J, and measure and release into a conical flask. Titrate J against K until the solution becomes permanent ink. Repeat 2 more titration times. Repeat more times and complete the table below. Let me give you the value of the table. 22.1, 21.9, 0.0, 0.0, 0.0. This one is 21.9, 22.1, 22.0. Let us go straight and get the average volume. Calculate the average volume of solution K. So this is solution K, and remember solution K is potassium permanganate. So the average is 22 plus 21.9 plus 22.1 divided by 3. This one is going to give us 22 centimeters cube. Calculate the number of moles of solution K reacting. Calculate the number of moles of solution K reacting. Also, you need to understand how to be aware of solution K. So when you forget, you go back. Solution K is 0.2 molar potassium permanganate, meaning that 0.2 is the number of moles in 1 liter. 1 liter equal to 1000 centimeters cube. So we ask here that 2 molar, 0.02 molar implies that 0.02 is the number of moles contained in 1000 centimeters cube of solution K. 22, because the volume used is 22 centimeters cube, K will contain how many moles? So it is 22 times 0.02 divided by 1000, and this one will give us 0.00044 moles. Determine, or given that the equation for the reaction is, this, determine the number of moles of iron 2 salt solution J in 25 centimeters cube of solution used. Now, let us first interpret this here. The permanganate is what we call solution K, The ion is solution J. What is the volume of the ion used? The volume, we took 25 centimeters because we pipetted 25 centimeters cube. 25 centimeters reacted with 22. Put K. Now we have the number of moles of K that reacted with J. The number of moles is this one, 0.00044. We can see that the ratio, the mole ratio is 1 to 5. So the manganese or the manganate ion to the ion, the ratio is 1 to 5. But we know the number of moles of this, which is 0.00044. So if 1 is equal to this, 5 will be what? That means it is 0.00044 times 5 divided by 1. So when we give us 0.0022 moles. Determine the morality of solution J. Morality. Like I have always said, what is morality? Morality is the number of moles in 1 liter. Morality is the number of moles of a solution in 1 liter. So J, we know the number of moles of J in 25. This is the number of moles. What will be the number of moles in 1 liter? 25 centimeters cube. Solution J contains 0.0022 moles. 1,000, that is a liter cube. Solution J contains how many moles? That is the number of moles in 1 liter of J. Determine the concentration of solution J in grams per liter. Grams per liter. So J, how was J prepared? So you go back to the procedure and then you realize, like this one, the ammonium ion, which is solution J, remember solution J is the ammonium ion, was made by dissolving 8.5 grams in 250, because the total volume distilled water plus this HCl will form plus 200 will form 250 centimeters cube, because the volumetric flask of 250 will contain a volume of 250 centimeters cube. So 8.5 grams of the salt was dissolved, making a solution of 250 centimeters cube. We want mass in grams per liter. So concentration in grams per liter. So you ask 250 centimeters cube solution J was prepared by 8.5 grams of the salt, and then 1,000, because a liter is 1,000 centimeters cube. J will contain how many moles? 1,000 times 8.5 divided by 250. This one will give you 34 grams per liter. Next question. From the result in 3 above, 3C, this is C Roman 3 above, determine, this question is misplaced, the formula mass, which is the RFM, so it is supposed to be here. Determine the RFM of the ion 2 salt, hence calculate the value of N in the formula. this formula. So first we calculate the RFM. This question is just misplaced here. It was supposed to come before this one. So let us see how to calculate the RFM. There is always this triangle I will always give you. Morality, RFM, mass in grams per liter. So once you have mass in grams per liter of a substance, you have the molarity of that substance, you will get the RFM very easy. So RFM is equal to mass in grams per liter divided by molarity. We are talking about the iron 2 salt. We have, which is solution J, we have the mass in grams per liter, which is equal to 34 divided by molarity. We have calculated the molarity of the solution, which is in Roman 2. We have calculated the molarity of the solution, which is 0.08 am. So 3.4 divided by 0.088, which is the molarity of the solution J. This one, using your calculator, you will get it is 386.4. So that is the RFM. But we know that the RFM is this of this formula. When you add each mass of each element, the mass of each element here, you will get this. So it means that ammonium, this ion, when you add everything here, you will get this 386.4. But we have been given N for nitrogen is 14. We have all the atomic mass of each element here. So this one is 14 times 2 plus hydrogen is 4 times 2 because hydrogen is 1, 8. Sulfur is 32 plus 16 times 4 is 64 plus iron is 56. Sulfur is 32. This one is 64. That is 16 times 4 plus, because this dot is a separation. Water is 16 plus 2, which is 18. 18 times this, it is 18N, which is equal to 386.4. Add everything here, you will get 284 plus 18N equal to 386.4. Like terms together, 18N is equal to, you subtract this here, is equal to 102.4. You divide it by 18, you find that N is equal to 5.688, which is equivalent to 6. So that is the value of N in this salt. Determine the correct formula for the ion. So the formula, we are going to replace N with a 6. Like that. You are provided with 1 ammonobasic acid HCl solution A. Ammonobasic base XOH RFM is 40, containing 1 gram of solute dissolved in 250 of distilled water solution B. So that is what you should mark, that 1 gram of this monobasic base was dissolved, 1 gram was dissolved to form or to make 250 centimeters cube. So 1 gram, this is 1 gram per 250 centimeters cube. This is the mass in 250. So in case you want per liter, you know what to do. So you will ask, if 1 gram is in 250, what about 1000 centimeters cube? So this is 1 gram in 250. Solution C, containing 28.6 grams of sodium carbonate and water, dissolved in 1 liter of water. So here it means that 28.6 grams was dissolved to form 1 liter. Therefore, this is the mass. This is the mass in grams per liter. Therefore, 28.6. It is the mass in grams per liter of solution C. So what are you required to do? You are required to standardize solution BA with solution B, and then determine the number of moles of water of crystallization in the formula, in this formula. So let us look at the procedure. Pipette 25 of solution B into a 250 centimeters cube conical flask. Add 2 to 3 drops of methyl orange indicator. Fill the burette with solution A and titrate with solution B. Repeat the procedure twice to attain a concordant results. Enter your results in the table below. So I'm going to give you the values. So our values today, we are going to use 12.4, 12.5, and then 12.6. So our initial we will take to be 0, 0.0, 0.0, and our difference here, arithmetic difference, is going to be 12.4, 12.5, 12.6. So our average, we go ahead and calculate out the average. That is 12.5 plus 12.4 plus 12.6, and then we divide by everything by 3. This one is going to add 1 here, so the average is 12.5 centimeters cube. 12.5 centimeters cube, that is our average. Okay, so let us see the next question. Calculate the number of moles of solution B. Remember, you need to understand the procedure itself first. Solution B is reacting with solution A. And what is solution B? Solution B is a base, which is could be sodium carbonate, sodium hydroxide, magnesium. We don't know, but it is a monobasic, so it could be potassium hydroxide. But since RFM is 40, we can guess, but we don't want to guess. Therefore, we know it is a base plus an acid HCl, so we should know that. So B, we can get the number of moles of B from this information. So we have 1 gram dissolved in 250. That one is easier because we have RFM, we have mass. Number of moles is simple. So let us go back. You remember this triangle here. Moles or mass, RFM, mass. No, we have mass, moles, sorry, moles. So how do you get moles? Moles is equal mass over FM. So moles, because we are asked to calculate moles of B, and B we see. We know B, it was 1 gram. 1 gram, where is it? 1 gram. 1 gram dissolved in 250, but the RFM is here, so we can get the number of moles in 250. Number of moles in 250 is simple So moles equal to mass over Fm. Our mass is 1 divided by Fm, which is 40, which will give us 0.025 moles. 0.025 moles. That is the moles of solution B in 250. Very good. That's one way you can do it. There is another way you can do it, but I don't want to go for that long way. That is the simple way and the easier one. So calculate the number of moles of solution A used. Solution A used. Calculate the number of moles of solution A used. So let us go back and see what was solution A. Solution A is a monobasic acid solution A. So solution A has reacted with B, and we know the number of moles of B in 250. So that one is easier. So let us see. Remember these moles. Ukumbuke kwamba hizi moles tuko nazo hapa ni za nini? Ni sa solution B, lakini volume ya solution B ilikuwa 250 cm3. Lakini B tumetumia P kiasi gani? P we just pipette 25 of solution B into. So solution B reacted with A. 25 cm3 of solution. 25 cm3 of solution B reacted with 12 cm3 solution A. Sasa tuwezi tumia moles za solution B zikiwa zote kwa 250. No, we just find now. We want to know if 250 of solution B has these moles, what will 25 of solution B contain? What will be the number of moles in 25 cm3 of solution B? Yes. So let us look at this. Oh, wait, see, changes the color. Oh. Okay. So we say 250 cm3 solution B contains 0.025 moles. 25 cm3, the one that reacted with B will contain what? So it is 25 times this divided by this, which will give us 0.0025 moles. Yes. Now we know the number of moles of A. Automatically we are going to know the number of moles of B. Automatically now we know the number of moles of B that reacted with A. So we use the ratio because both of them are monobasic, therefore the mole ratio is 1:1, meaning that moles of B in 25 cm3 solution B, moles of 25 cm3 solution B will be equal to moles of 12.5 cm3 solution A. Okay, I have said that moles of 25 cm3 solution B will be equal to the moles of 12.5 cm3 solution A, because the ratio is 1:1. So moles of A is equal to 0.0025 moles. Why? The ratio is 1:1. This is a monobasic and a monobasic base, a monobasic acid, therefore they are going to, it's like sodium hydroxide plus HCl. The ratio is 1:1. So the moles is like that. So let us go ahead and finish the part D. Calculate the concentration of solution A in moles per liter. So concentration of a solution A in moles per liter simply means molarity. We are calculating molarity. Molarity is the number of moles in 1 liter. So we are going to ask that solution A, 12.5 centimeters cube, contain these moles, 0.0025. So we will ask 1,000 centimeters cube, which is the liter, will contain what? So it is times C divided by this, and it's going to give you 0.2 capital M. That is the molarity of solution A. Number of moles in a liter. We have finished, so we go to procedure 2. Procedure 2. Pipette 25 centimeters cube of solution C into a conical flask. Add 2 to 3 drops of methyl orange indicator. Fill the puree with solution A and titrate with solution C. So solution C, we are going to put it in a conical flask, 25. So C is 25, and then the conical water we are going to have from the puree is solution A. But we know a lot of information about solution A. First, we know the concentration, we know the molarity of solution A, the one we have just calculated here. So we know the molarity of A. Molarity of A, we know it is 0.2 capital M molarity. So it is simple. This one is going to be very simple because you need to connect. You need to connect from part A, procedure 2, procedure 2. So you have to connect. So here I'm going to give you the procedure or the volume. The volume is 24.9, 25.0 and 25.1, 0.0, 0.0, 0.0. So let us do our mathematics here. Initial is that, and then this is 24.9, this is 25.0, and this is 25.1. Our average is 24.9 plus 25.0 plus 25.1 divided by 3, which is going to give us 25.0 centimeters cube. Calculate the number of moles of solution A used. Number of moles of solution A used. But we know the concentration of solution A. 0.2 capital M solution A implies solution A implies that 0.2 is the number of moles where in 1,000 centimeters cube. So we are going to ask 25 centimeters cube of solution A will contain how many moles? So 25 times 0.2 divided by 1,000 will give us the number of moles that reacted there. So that one will give us 0.005 moles. They have given us the equation. This equation you are supposed to write it yourself, but now thank God they have given us. You can see that the ratio is 1 to 2. The carbonate ratio is 1 and this is 2. So given the equation below, calculate the number of moles of solution C. Remember, solution C is the carbonate, sodium carbonate, right? So but here we have used solution, this is 25 centimeters cube. This one also 25 centimeters cube, but we know the number of moles of this, which is 0.05. We know the number of moles of this, 0.05 moles. But the ratio is 1 to 2. So if 2 is equal to this, then what will be this? So moles of sodium carbonate is going to be a half times 0.005, which is going to give us 0.0025 moles. I have of it. Calculate the concentration of solution C in moles per liter. So we want to calculate the molarity of C. Molarity of C. But we know C, we used 25 centimeters cube of C. So this number of moles that we have here, this one is the number of moles of solution C in 25 centimeters cube. So what about 1,000? And that is molarity. 25 centimeters cube solution C equal to 0.0025 moles. 1 liter centimeters cube, 1,000 centimeters cube equal to 1 liter. Solution C will be what? And this one will give you 0.1 capital M. 0.1 capital M. That's what the molarity of solution C is 0.1. Let's go to the next page. So the next question is determine the relative formula mass of C. The relative formula. So we want to calculate the RFM of C. So I want to remind you of this triangle here that says that molarity RFM mass, which must be grams per liter. That mass of whatever you are looking, we must be in grams per liter. But we have mass in grams per liter of solution C. So here, solution C contains this, ndio hii, 28.6 grams per liter. So we know the mass in grams per liter of solution C. Here again, we have the molarity here. The molarity of solution C is here. We have the molarity of solution C, 0.1. Now using this formula, sorry for that. So we are going to say now that RFM of solution C is equal to mass in grams per liter divided by molarity. Mass in grams per liter is 28.6. Molarity is 0.1, which is going to give us 286 grams. That is the RFM. The RFM of that is 286. Very simple. Determine the number of moles of water of crystallization of C. This, remember, C is sodium 2 carbonate dot N water. So we want to look for this value. But when you add everything in this salt, which is sodium carbonate with some water of crystallization, the answer should be the RFM, which is 286. So what is missing here? They should have given us that sodium equal to 23, oxygen equal to 16, hydrogen equal to 1, sodium or carbon equal to 12. So once we have all that, we can go ahead and do it. So let us calculate this one. So sodium, that is 23 times 2 for sodium, plus carbon, which is 12, plus oxygen, which is 16 times 3, plus N times 18, which will give us 286. This plus this one will give us 106 plus 18N equal to 286. Like terms together, 18N is equal to 286 minus 106. So 18N equal to 180. So divided by 18, and the N is equal to 10. So N is equal to 10, meaning that this formula is sodium 2 carbonate 0.10 water. Thank you. Thank you for your time, and thank you for supporting this channel. May you be blessed a lot. Thank you.